Hi everyone. So before closing this chapter and jumping onto the assignment, first we will see a very small topic which is wave polarization. A very interesting topic. We just need to study the locus of electric field. Okay, by the definition you are not understanding anything. That locus of tip of electric field in a plane perpendicular to the direction of propagation. You might not be able to understand the definition, but let's understand it with respect to an example. So this is an electric field equation is given E naught cos omega t minus beta z x cap. So E field is dancing in x direction. E field is dancing in x direction and wave is propagating in z direction. So this is the direction of wave propagation, right? This is the direction of wave propagation, and E field is dancing in plus x and minus x, plus x minus x. This is how it is dancing. Now in the direction of propagation, we need to take a perpendicular plane. You see this line, locus of a tip of the electric field in a plane perpendicular to the direction of propagation. So this is the direction of propagation. Now in the direction of propagation, I need to take a perpendicular plane. So if this is the direction of propagation, then what will be my perpendicular plane? So this will be my perpendicular plane, right? This will be the perpendicular plane. Can you write down the equation of this plane? Z equals to 0. It could be anything. It could be Z equals to constant as well. But I am taking Z equals to 0 plane. I am taking Z equals to 0 plane. Okay, so XY plane is my Z equals to 0 plane. So now on this plane, I need to study the tip of this electric field. What do I mean to say is that if I look from here, then how will my electric field look like? This is your X, this is your Y. This is your X, this is your Y. I am looking from here. This plane is Z equals to 0. This plane is Z equals to 0. So on Z equals to 0 plane, how will the electric field look like? So this is a picture at a certain time. This is a picture at a certain time. So initially this is my equivalent vector. Now what will happen? I will click the time button. Just as I click the time button, this guy will come ahead. What do I mean to say is that on this plane, first this is my equivalent vector. Then what will happen? Just as I click the time button, then this guy will come in action. The other guy will come in action. Which guy? This small guy will come in action. Then again if I click the time button, then this guy will come in action. Basically it is moving ahead, no? This wave is moving ahead. So now this will come in action. Then 0 will come in action. Then this small guy will come in action. Then this guy will come in action. Then this larger guy will come in action. So what you will see is that on XY plane, if you see from XY plane, you will feel like that it is moving like this. The tip is moving like this. Let me show you the animation. Okay, so credit goes to this website CCDMO. Credit goes to them. So if my wave is propagating like this, so you can see this will be the tip. This is how it will look like. The tip will first start from here, then it will go down, then it will start, it will go down, it will go down. Are you able to see the tip? So in a line, it will be keep on moving, right? If this is my wave propagation, if this is my direction of wave propagation, so I will take a perpendicular plane. This is how my wave is going. I will take a perpendicular plane here, and then I will look from this side. I will look from this side, from here, that how this wave would be looking. So the wave would be looking like a line. So this is known as linear polarization. Okay, we will write down the conclusions one by one. We will write down the conclusions, but this is known as your linear polarization. Are you able to get this point? The wave was propagating in Z direction and electric field was in X direction. Electric field was dancing in X direction. So I took a plane perpendicular to the direction of propagation. Took a plane perpendicular to the direction of propagation. So now I need to study the tip of this electric field. So initially this was my equivalent, then this was my equivalent, then this was my equivalent, then 0 was my equivalent, then this was the equivalent, then this was the equivalent, then this was the equivalent. Again what will happen? This guy will come in action. Then 0 will come in action, then this guy will come in action, then this guy will come in action, then this guy will come in action. So the tip is moving like this. You can see here as well. From 0 to in this manner it is keep on moving. Is that clear to you? Okay. So this was one of the example. We will write down the conclusion. But first we need to understand what do we mean by polarization. So we are studying about electric field, and whenever the word polarization comes, you need to think about E field only. It has nothing to do with H field. We have studied oblique incidence, right? In oblique incidence we studied parallel polarization, perpendicular polarization. So we were defining with respect to electric field, not with respect to magnetic field. Parallel means electric field was parallel. Perpendicular means electric field was perpendicular to the plane of incidence. So it is always associated with the E field only. So this is how my E field will look like. E field will look like. What do you think? How my E field will look like in this example? In this example, how will my E field look like on XY plane? On which plane? On XY plane. So this is X, this is Y. and I need to take a plane perpendicular to the direction of wave propagation, perpendicular to the direction of wave propagation. So this kind of plane I am taking. Now in this plane, along y, first you are having that along y, along positive y, this will come. Are you getting this point? This equivalent vector will come along positive y. Along positive y, this equivalent vector will come. Then this will come. Then this will come. Then 0 will come. Then 0 will come. Then along negative y, this equivalent will come. You can see the equation. Equation is cos omega t minus beta z ay cap. So now my electric field is dancing in y direction. Then this equivalent will come. Then this equivalent will come. Then again this equivalent will come. Right? In that manner it will keep on going. So it will be keep on dancing on y axis. So it is a line only. So it is known as linear polarization. Did I wrote the name here? No, it is known as linear polarization. So first we are understanding the meaning, then we will see how to solve the problems. But first understanding the meaning is also important. This is also known as linear polarization. Let me show you the simulation. Not simulation actually, it is known as animation. So this is how you can see the animation. Okay, this is how it would be moving. You can see the animation here, right? And you are able to visualize as well. It is pretty simple. Now let's see this. Now electric field is dancing in x direction as well, it is dancing in y direction as well. What you need to do? You need to take the plane perpendicular to the direction of propagation. What is the direction of propagation? The direction of propagation is in z direction only. The direction of propagation is z direction only. So I need to take perpendicular to the direction of propagation. So that plane is z equals to 0, and z equals to 0 is xy plane. It's not necessary that you take z equals to 0. You can take any plane z equals to constant. This plane also I can take. Anywhere I can take a plane. But what I will take for analysis purpose, I am taking z equals to 0. I am just analyzing the equivalent at this particular place. Is that clear to you? So what do you think? What will be the equivalent? So this is your x, this is your y. So initial vectors are on x direction, this is the vector. On x direction, this is the vector, and on y direction, this is the vector. On x, this is my electric field, on y, this is my electric field. So what will be the equivalent? This will be the equivalent. So this is the equivalent of first one. Then what will happen? Then what will happen? This small guy will come, this small guy will come, this small guy, and then this small guy. Basically, I am putting the time button. So these are moving now. These vectors are moving. So this small guy and this small guy. So what will be the equivalent? This will be the equivalent, right? Now you can think of other equivalents. Which guys will come now? Now these guys will come in action. So along x there is something, and along y there is something, and along y there is something. So now I need to take equivalent. So equivalent will be something like this. So in that manner we will be going. Then 0 will come. Equivalent of 0 is 0 only. Equivalent of 0 is 0 only. Now what about this? Along minus y and along minus x. Are you able to see this y? Are you able to see this? Along minus y and along minus x, right? So along minus y and along minus x and along minus x. So what will be the equivalent? This small will be the equivalent. Now in that manner other guys will come and the equivalent will look like this. This will be the equivalent. Then this will be the equivalent. So in that manner it will keep on going, right? So how it will be dancing? This is also linear polarization. This is also linear polarization. Certainly in this manner we are not going to solve in the examination. In examination how will you solve, that also I will tell. So do not worry about that. Linear polarization. Okay. Let me see if I can get any animation. Let me check it. Yeah, so this animation we can see. Basically there are two waves. You can see the waves. There are two waves here. Red one is along x axis, and or it is x or y. In our example, red one is along y axis actually. In our example, red one is along y axis and green one is along x-axis, and equivalent is this blue one. Red is the x-axis one, so red is the y-axis one, and green is the x-axis one, and this blue is the equivalent. So you can see how equivalent is going. You can see the equivalent vector. Do not look at this red and green, just look at the equivalent vector. So this is how your equivalent vector is going. So it is feeling like, it feels like that it is a linear polarization, or it is a linear line only. This is how the line is going. So that is known as linear polarization. Okay, so this is known as linear polarization. Let's see more examples. Yeah, so here I will tell you how to solve in the examination. Now I am gonna tell how to solve in the examination. Okay, so problem solving. This is also example of linear polarization only, but how we will solve it? What I know, that I am looking at xy plane only. I am looking at xy plane only. So whatever my direction of propagation would be, I will put that equals to 0. Basically, I will put z equals to 0, because where I am standing on xy plane, and xy plane means z equals to 0. Xy plane means z equals to 0. So in the equation, I will put z equals to 0. If it was propagating in x direction, if it was beta x, and here also it was beta x, then I would put x equals to 0. If it was beta y, then I would put y equals to 0. Because I just need to take the direction, I just need to take a perpendicular plane to the direction of propagation. So this is my direction of propagation, so I need to take a perpendicular plane. So at that plane, z equals to 0 or y equals to 0 or x equals to 0 would be my equation of plane. So now what will be the equation of this plane? That would be z equals to 0. Without even drawing this diagram, you would get to know that I am going in z direction. That means my perpendicular plane will be z equals to 0. So I will just put z equals to 0 here. What I am gonna do, I will just put z equals to 0. So what I am gonna get? E naught cos omega t ax cap plus E naught cos omega t plus pi ay cap. So what is pi plus cos pi plus theta? All student take. So t negative. So it is negative only. So what you are getting? Minus E naught cos omega t ay cap. Now I need to draw the equivalent in the direction of x and y. So this I am calling as x, this I am calling as y. You can call anything, right? You can call this as y, or this as x, or this as x, this as y. I am just calling this as x, this as y. Okay. Yeah. So now let's draw the equivalent. So with respect to time, I will draw. Basically, this was the picture at time t equals to 0. If I click on the time button, then this equivalent vector will start moving, right? This was the picture at time t equals to 0. If I click on the time button, then these equivalent vector will start moving, and we will get the waveform on this plane. This is what we were doing here. Initially, this was the equivalent, then this was the equivalent, then this was the equivalent, then 0, then this. In that manner we were going. So this was the t equals to 0 time. Then we clicked on the time button, and then these equivalent vectors started moving. So same thing we are going to do here. What we are going to do, first we will see at time t equals to 0. At t equals to 0. So cos 0 is 1 only. So what is your E naught? E naught is at time t equals to 0, E naught ax cap, E naught ax cap minus E naught ay cap, right? So in x direction you are having E naught, and in y direction you are having minus E naught. Basically in minus ay direction, you are having minus E naught. So this is your equivalent vector. So you will only draw equivalent vector. What you are going to draw, you are only going to draw equivalent vector. So this you go to know that this is my first equivalent vector. Then second you will see at t equals to t by 8 you can take. Okay, at t equals to t by 8. So at t equals to t by 8, what will be your omega t? At t equals to t by 8, your omega t would be 2 pi by t into t by 8. That would be pi by 4. So omega t will be pi by 4. So what will be cos pi by 4? That would be under root 2. So E naught by under root 2 ax cap minus E naught by under root 2 ay cap. Okay. So E naught by under root 2 ax, E naught by under root 2 ay. So what will be the equivalent? Equivalent will be, this will be the equivalent. Then second equivalent you will be able to make. Now just as you make two equivalent, you will get to know that certainly it is linearly polarized. Okay. You will build up the habit, because there are only three kind of polarization possible: linear, circular and elliptical. So just here only you will get to know that it is our linearly polarized wave. Okay. Now you can take more like you can take more time instants. You can take at t equals to t by 4. Let's see what you are gonna get. So what will be your omega t? 2 pi by t into t by 4. What that would be? Pi by 2. So cos pi by 2 is 0. This is also 0. So you are gonna get 0 only. So this will be the equivalent. 0 only. Now if I take at t equals to t by 2 also I can take. Okay. So what will be the equivalent? So 2 pi by t into t. T by 2 I am taking. So that would be pi. So what is the value of cos pi? That is minus E naught ax cap, and this will be plus E naught ay cap. So E naught ay cap and minus E naught ax cap. So this will be the equivalent, right? So you can see this is my equivalent. So in the examination, you do not need to draw these waveform. You just need to put z equals to 0. Wherever your wave is propagating, in whatever the direction wave is propagating, you just need to take the perpendicular plane, and that perpendicular plane will be certainly z equals to 0. If it was propagating in x direction, then it would have been x equals to 0, and if it was propagating in y direction, then it would have been y equals to 0. So you just need to put here z equals to 0. Then at different time instant, you just need to take the equivalent vector, that how my E field will look like. So this is how my E field is looking like. Like if at some other time instant this would be the equivalent, at some other time instant this could be the equivalent. So basically your E field will be going on this line only. Okay. Now in the examination they can ask you this angle, or they would ask you this angle. Angle made with x axis or angle made with y axis they can ask. So what do you think, what will be your angle made with y axis here? What do you think? Angle made with y axis I am asking. So what you need to do, you need to take any equivalent vector. Let's just say if I take this equivalent vector, what it is saying, minus E naught minus x minus E naught ax cap and E naught ay cap. I am talking about this guy, okay? Minus E naught ax cap and plus E naught ay cap. So what will be the equivalent? This will be the equivalent. So what will be the angle? This angle would be E naught divided by minus E naught. So angle would be 45 degree. Are you getting this point? Basically I need to take equivalent. All the equivalents are coming on this line only. All the equivalents are coming on this line. So I can take any equivalent. I can take this equivalent as well. What they are saying, that E naught by under root 2 in x direction and E naught by under root 2 in minus ay direction. So this will be the equivalent. So what will be this angle? What do you think? This angle would be E naught by under root 2 divided by E naught by under root 2. So that would come out to be 1. So this angle will be 45 degree. Now what they are asking, if they are asking this angle, I can take this will also be 45 degree. If they are asking this angle, then what it would be, it would also be 45 degree. They can say whether you need to tell the angle in anti-clockwise direction or clockwise direction. If they are asking in anti-clockwise, then I will say this is 90 plus 45, it would be 135 degree. And if they are asking in clockwise direction, then I will say it is 45 degree. So these kind of things they can ask. So they will just ask you to draw the like polarization, and then they will ask you the angle. Okay. So that thing you can simply solve by geometry, and for geometry you just need to take anything in action. Like one of the thing I can take in action, I can take this guy in action, and then I will see what is the equivalent vector and what will be the angle, right? Okay. So in the same manner, I want you to solve more problems. So this is the conclusion we have written. Now in these examples, what do you see? What is the phase difference between this guy and this guy? Phase difference was pi. Here phase difference is 0. I am writing phase difference 0 degree. Here phase difference was pi. In the previous example as well, phase difference was, here also it was 0. Okay. There is no phase difference actually. In these examples, there is only one wave. Like here, there is only wave is dancing only in y direction. Here wave is dancing only in x direction. But in these examples, it was dancing in xy direction. In these examples, it is dancing in xy direction. So phase difference was pi here. Here it was 0. So whenever your phase difference is a multiple of pi, multiple of pi, not pi, sorry, multiple of pi. That means if phase difference is 0 or plus minus pi or plus minus 2 pi or plus minus 3 pi, in that manner, if that is the phase difference, then certainly your wave will be linearly polarized. Okay. Whenever your phase difference is multiple of pi, then certainly your wave will be linearly polarized. 0 plus minus pi plus minus 2 pi plus minus 3 pi. And if they ask you the angle made with x axis, then you can say tan inverse E naught y by tan inverse E naught x. No need to mug up this formula. If they are asking the angle, then you make this geometry. You make this geometry and quickly you will be able to tell the angle. Is that clear to you? So for angle, I am not asking you to mug up any formula. You can quickly make the geometry and tell the angle. The concept is clear. How to solve the problem, that is also clear, right? Everything is crystal clear. One thing, just this you can keep in mind, that if phase is a multiple of pi, then it will be linearly polarized. And if phase is multiple of pi by 2, then it would be circularly polarized. So that we are going to see now. Okay. So let's solve this example, that then we can see it. So try solving it on your own. I will take a break, drink some water, and then I will explain it. You can try solving it on your own. You first you tell me what is the phase difference between this guy and this guy. Think smartly. Okay. Take your time. Think smartly. Sine, cos. So take your time and tell me the phase difference. Then you tell me the angle made with x-axis. Okay. Take your time. I will drink some water and then I will start solving it. Yeah, so let's start solving this problem. You need to first tell the type of polarization and then you need to tell the angle made with x-axis. So assuming that only this question was asked in the examination, they did not ask angle made with x-axis. So for this question, the type of polarization, you do not need to make any geometry. Without even making the geometry, you can tell the angle. Sorry, you can tell the type of polarization. How you can tell the type of polarization? By just looking at the phase difference. So what is the phase difference between these two? If you know the phase difference, then you can tell the type of polarization. If my phase difference is coming as pi or 0 or 2 pi or 3 pi or minus pi or anything, then I will be able to tell that it is a linear polarization. Okay. But if you need to tell the angle made with x-axis, then I highly recommend to go making the geometry. Is that clear? Okay. So first let's solve with the regard that only this question was asked. So what I would have done in the examination, that I need to check the phase difference. So one guy is cos, other guy is sine. So you need to make both of them either cos or either sine. Cos or sine. So that you need to do. So what I do is that I will always convert cos into sine. This is my habit. You can convert sine into cos as well, but my habit is that I will always convert cos into sine. Okay. So what is my formula? The formula is, here I will write down. So sine pi by 2 plus theta. Sine pi by 2 plus theta is equals to cos theta, right? Sine pi by 2 plus theta is equals to cos theta, because in second quadrant sine is positive. So this is theta. So cos theta, and if I need to convert it to sine, what I'm gonna do? I'm gonna just add pi by 2. Are you getting this point? E naught as it is. Cos theta. If this is your theta, then if I need to convert it into sine, then what I need to do? Sine and add angle pi by 2 in this one. So what I will get? Omega t minus beta z plus pi by 3 plus pi by 2. So another pi by 2 I need to add, Ax cap, and this sign will remain there as it is. So E naught by under root 3 sine omega t minus beta z minus pi by 6 Ay cap. Now what is the phase difference? Here it is having the phase of sine omega t minus beta z and this angle, and this is having the phase of sine omega t minus beta z and this angle. So what is the phase? The phase is pi by 3 plus pi by 2. This guy is having this phase minus this phase. What this guy is having the phase? This guy is having the phase of minus pi by 6. Okay. This phase is 90 plus 60. So this phase is 150 degree and this phase is minus 30 degree. So 150 minus minus 30, what that would be? 180. So the phase is pi. Phase is pi. And if the phase is pi, that means certainly it is linear polarization. So that will be the answer of first question, if they are only asking the type of polarization. But in the examination, if they are asking the angle made with x-axis, then I do not recommend applying this formula. What I recommend drawing the geometry. So draw the geometry and then tell the answer. Okay. So you need to tell angle made with x-axis. So how will you draw the geometry? I will put z equals to 0 and then I will draw the diagram on xy plane, and then I will put t equals to 0, t equals to t by 4, t equals to t by 8. In that manner I will go. So what I need to do? I need to draw the diagram. So on xy plane I will be looking at, because my wave is propagating in z direction. So what will be the perpendicular plane? Perpendicular plane will be xy plane. And what is the equation of xy plane? Equation of xy plane is z equals to 0. So I will put z equals to 0. So what will be my Ex at z equals to 0? So that would be E naught cos omega t plus pi by 3 Ax cap plus E naught by under root 3 cos omega t minus pi by 6 Ay cap. This was sine actually, not cos, this was sine. Okay. Now I need to put t equals to 0 and t equals to t by 8 or anything I can do. So let's put t equals to 0. So if I put t equals to 0, this will be cos 60. What is cos 60? 1 by 2. So what you are getting? Ex. What you are getting at t equals to 0. So E naught by 2, t equals to 0. So cos 60, cos 60, and it is 1 by 2, E naught by 2 Ax cap. And what about this? Sine minus 30. Sine minus 30, that is 1 by 2 only. This is also 1 by 2, right? So minus E naught by under root 3 1 by 2, because this is sine minus 30, sine minus 30. So sine minus 30 is equals to minus sine 30. So minus sine I am taking outward, so that would be 1 by 2 only, 1 by 2 Ay cap. So if I draw on xy plane, they are asking me the angle made with x axis, right? They are asking me the angle made with x axis. So I will take x on horizontal and y on vertical, angle made with x axis. So E naught by 2 in x direction, E naught by 2 in x direction, E naught by 2, E naught by 2 by root 3 in y direction, E naught by 2 and E naught by 2 root 3 in y direction. What will be the equivalent? This will be the equivalent. This will be the equivalent. And this will be the angle. What will be the angle? Angle will be tan inverse E naught by 2 under root 3 divided by E naught by 2. That would be 30 degree. So this angle is coming out to be 30 degree. Now they are asking angle made with x axis. So from x axis, from positive x axis, you need to go till this vector. Are you getting this point? From positive x axis, you need to go to this vector. So in which direction you are moving? You are moving in anti-clockwise direction. Sorry, you are moving in clockwise direction. From positive x axis, you are going to this vector. So that means you are moving in clockwise direction, and in clockwise direction, angle are taken negative. So answer would be minus 30 degree. Are you getting this point? They are asking the angle made with the positive x axis. Angle made with positive x axis. So from positive x axis, if you need to go to this vector, then you need to move in a clockwise direction, and in clockwise direction angle are always taken negative. Or what could be the answer? Answer could be 330 degree. Why is that so? From positive x axis, I could have moved like this as well. No? From positive x axis, I could have moved like this as well. So how much angle this would be? 330 degree. And since I am moving in anti-clockwise direction, that's why I am putting positive sign. So answer could be 330 degree as well. So by taking a t equals to 0 only, I will get to know that this is my 30 degree angle. You can take more time instants to verify whether it is linearly polarized or not. Linear polarization has been verified here only. But if you need to do the time domain analysis, then also you can do at t equals to t by 8. So what will be my omega t value? Omega t value will be, it would be pi by 4. It would be tough to analyze. So better let's take t by 4. Better let's take t by 4. So it would be pi by 2. Now it will be easy. So Ex cos pi by 2 plus pi by 3. Cos pi by 2 plus theta is minus sin theta. So and minus sin theta, what is theta here? Theta is 60 degree. So under root 3 by 2. Under root 3 by 2. So E naught under root 3 by 2. But minus sign will be there. Then what about this? Pi by 2 minus theta is cos theta, and cos 30 is under root 3 by 2 only. So that is E naught by root 3 under root 3 by 2 Ay cap. So in x you are having negative, and in y you are having this positive. So what will be the equivalent vector? This will be the equivalent vector, right? So you can see we are moving on this line only. We are moving on this line only, right? Now someone will have a doubt that sir, my polarization is linear polarization. Basically, I will be moving on this line. Then how can you say that, sir, angle made with x-axis is not this one? So this answer is actually incorrect. 330 degrees should not be the answer. Why is that so? Because on this line, if you are moving, on this particular line, if you are moving, then angle made with x-axis can be defined like this, and this. Are you getting this point? Previously I said that this would be the angle, but I forgot the fact that here also there will be line, no? So this will be the angle, no? Are you getting this point? Right? So what could be the other answer? Other answer could be with positive x-axis, this line is making this angle. This could be the other answer. Okay. So if this is 30 degree, then this is also 30 degree. So this is 90 plus 30, this angle would be 120 degree. So other answer could have been 120 degree. Okay. One more answer could have been 120 degree. Are you getting this point? This would be the complete line, no? This would be the complete line. This is linear polarization. So from positive x-axis, if you go towards the line, then you will get the line after 120 degree. Why 120? Because this angle I know 90 degree, and if this is theta, this is also theta. Right? If this line and this line, if this is theta, this is also theta. So 90 plus 30, that is 120 degree. So answer could have been 120 degree as well. So that 330 was wrong. Okay. So if you draw this line, you will get to know that this is how my linearly polarized wave will look like. So you just need to tell that this angle will be 120 degree. So in the examination, by only making this diagram only, you will get to know that complete linearly polarized wave will look like this. Complete linearly polarized wave will look like this. So if this is 30, then this would have been 120. So that also you can tell in the examination itself, right? Okay. So two kind of questions can be asked from linear polarization, and everything we have covered. So the point is, this magnitude and this magnitude can be unequal, and the phase difference between them will be multiple of pi. Then it will be linearly polarized. Now we need to study circular polarization, but before that we need to study a concept of right hand circularly polarized and left hand circularly polarized. So as of now you do not know what is circular polarization, but just consider that you know circular polarization. Then if this wave is circularly polarized, this wave is also circularly polarized, this wave is also circularly polarized, and this wave is also circularly polarized. So if they are circularly polarized, then whether they are right hand circular polarization or left hand circular polarization, how will you tell? So how we need to tell? Now this dot and cross are pointing towards the direction of wave propagation. So our thumb should always be pointing towards the direction of propagation. Okay, listen to me very carefully. Our thumb should always be pointing towards the direction of propagation, and our finger should rotate in this polarization direction. The polarization direction is this. Polarization direction is this. You use your own hand. Thumb is pointing towards the direction of propagation, and finger should rotate in the direction of polarization. So which hand you need to use? If you see this diagram, the thumb is pointing towards the direction of propagation. That means it is coming towards you. This is the direction of propagation, and finger should rotate. Finger should rotate in the polarization direction. In this direction, finger should rotate. So you need to use your left hand, right? You do it from right hand. This is my right hand. Thumb is moving towards me, and if I move my hand like this, then where it is pointing? It is pointing in the opposite direction. But I need to use my left hand. So this is your left hand circularly polarized. What about this? Thumb should be pointing here and finger should be rotating in the direction of polarization. So it is right hand circularly polarized. Right hand circularly polarized. What about this? Thumb should be pointing here and finger are pointing towards the polarization direction. Finger should be rotating in this direction. Finger should be rotating in this direction, and thumb should be towards the direction of propagation. So this is the direction of propagation. So I am using my right hand. So this is right hand circularly polarized. Are you able to write down where thumb is pointing? Thumb is pointing towards the direction of propagation. That means going into the screen, and my hand should point towards the direction of polarization. So direction of polarization is this side. So I need to use my left hand. So thumb is going inside, and direction of polarization with my hands. Direction of polarization with my fingers. So thumb is going inside and finger are rotating like this. So this is left hand circularly polarized. So you should be able to understand this point. At least this point you should be able to understand. I hope you are able to do it with respect to your hands. Is that clear to you? Yes. Now let's study circular polarization. So in the same way we are going to analyze. Same way, we are not going to draw the electric field, we are not going to draw the magnetic field, or we are not going to see the direction of propagation. What was the way we were analyzing? We will put z equals to 0, we will sit on xy plane and we will see what is our locus. So I just need to see the locus. So how I will see the locus? I will put z equals to 0. So if I put z equals to 0, it will look like this: cos omega t ax cap plus E naught cos omega t plus pi by 2 ay cap. I can make it better: E naught cos omega t ax cap. What is pi by 2 plus theta? Minus sin theta. Minus sin omega t ay cap. So I am standing on xy plane. On xy plane. Anywhere I can make x, anywhere I can make y. So this is my xy plane. Okay. So let's start making the equivalent. So first let's see at t equals to 0. So at t equals to 0, what you are going to get? E naught ax cap, because cos 0 is 1. And what about sin 0? Sin 0 is 0 only. Sin 0 is 0 only. So in y there is nothing. So at t equals to 0, this is my equivalent. This is my equivalent at t equals to 0. At t equals to 0. Let's take the equivalent at t equals to t by 8. So what will be my omega t value? Omega t, 2 pi by t into t by 8. That would be pi by 4. So omega t value will be pi by 4. Okay. So what is cos pi by 4? E naught by under root 2. E naught by under root 2 x cap. And what is sin pi by 4? E naught by under root 2 ay cap. So in x direction E naught by under root 2, and in y direction E naught by under root 2. In minus y direction E naught by under root 2. So what is the equivalent? This is the equivalent. Right? So equivalent is this. This is the equivalent. And if you need to take the magnitude of equivalent, what will be the magnitude? Here what is the magnitude? Magnitude is E naught only. What will be the magnitude here? E naught by root 2 whole square plus E naught by root 2 whole square. Right? If I am talking about magnitude. So magnitude is E naught only. So this was also E naught. This is also E naught. This was the direction. Now this is the direction. Now let's take more points. Let's check at t equals to t by 4. Okay. So at t by 4 it will be pi by 2. So this will be 0. And what about this guy? This guy will be 1. So minus E naught ay cap. Minus E naught ay cap. This will be minus E naught ay cap. At one more direction we will check. Let's check at t equals to t by 2. You can check at 3t by 4 as well. I am checking at t by 2. So what you are going to get? 2 pi by t into t by 2. That will be pi only. So cos pi is minus 1. So minus E naught ax cap and sin pi is 0. So minus E naught ax cap. So this is where we are getting. So what you are getting to know, in between somewhere you will get here. So in that direction, we started from here, and in this direction we are moving. So on the circular direction we will keep on moving. So what will be our polarization? Our polarization will be circular polarization. Okay. Our polarization will be circular polarization. This is how we will keep on getting the equivalents. This is not a perfect circle, but yeah, you will understand. So how we are moving? We are moving in this direction. At t equals to 0, we started from here. At t equals to 0, we started from here. Then at t equals to t by 8, I came here. So how will I make my arrow? I am walking in this direction. So this is how I will make my arrow. This is how I will make my arrow. Okay. Now what is my direction of wave propagation? Direction of wave propagation is plus z. Direction of wave propagation is plus z. X cross y should give me plus z. So plus z would be towards this. Right? So my direction of propagation is towards me. So which hand I need to use? Left hand. Because thumb should point towards the direction of propagation and finger should move in the direction of polarization. So direction of polarization is this, and finger and thumb is towards the direction of propagation. Is that clear to you? Finger is moving like this and thumb is towards the direction of propagation. So I need to use left hand. So this is known as left hand circularly polarized. Now if a question comes in the examination, then how would you solve it? First you will see the phase difference. Phase difference is pi by 2 and certainly it is circularly polarized. Now if they are asking you whether it is left hand circular polarized or right hand circular polarized, so you just need to check at two instants. You check at t equals to 0, you check at t equals to t by 8. You will get to know that in which direction I am moving. If I had checked only these two, then would I be able to tell that in which direction I am moving? Yes, I am moving in this direction. If I check at only two instants, then I will be able to tell in which direction I am moving. I am moving in this direction and my thumb should be pointing towards my face. My thumb should be pointing towards my face because this is the direction of wave propagation. So I need to use left hand, so it will be left hand circularly polarized. Is that clear to you? So this is how you should do the analysis. Okay, let's see more question. Let's do more practice. Now phase is minus pi by 2. Here it was plus pi by 2, or you can say here it was minus pi by 2, but here the phase difference is pi by 2. Okay, so now phase difference is pi by 2. You do the analysis on your own and you let me know that which kind of polarization is that, and you let me know whether it is left hand circularly polarized or right hand circularly polarized. Okay, so let's do it. So what I'm gonna do, put z equals to 0. If I put z equals to 0, then my E is E naught cos omega t Ax cap plus E naught cos omega t minus pi by 2. That will be sine omega t only. Okay, basically here you put z equals to 0, so cos omega t minus pi by 2 minus theta is sine theta, so that would be sine omega t only. Okay, so this is my E, this is my electric field. Now I need to check at different time instant. So at t equals to 0 I am gonna check, and which plane I am gonna make, xy plane only. Why xy plane? Because I am gonna put z equals to 0, so I am looking at xy plane only. So this is my xy plane. This here I am making x, here I am making y. Where will be my z? This will be my z. Okay, x cross y should give me z, so this will be my z. At t equals to 0, E naught Ax cap, and that would be 0 only. So at t equals to 0, I am here. Now I cannot tell whether it is left hand or right hand circularly polarized, because by using only one vector I cannot tell, but using two vectors I can tell. This was at t equals to 0. Now at t equals to t by 8 if I check, so what will be my omega t value? Omega t value will be 2 pi into t into t by 8, so that will be pi by 4. So omega t value is pi by 4. So E is E naught by root 2 Ax cap plus E naught by root 2 Ay cap. So E naught by root 2 Ax cap, E naught by root 2 Ay cap. So what will be the equivalent? Equivalent will be in between. So here I am getting my equivalent, and from here I will get to know that in which direction I am moving. I will move in this direction, right? So this is at t equals to t by 8. Do I need to analyze further? No. Why I don't need to analyze further? Because now I am understanding that in which direction I will move. So I will move in this direction only. I will move like this. So in which direction I am moving? In this direction I am moving. So thumb should point towards the direction of wave propagation and finger should be pointing in the direction of polarization. Thumb should move towards the direction of propagation and finger should be pointing towards direction of polarization. So which hand I am using? Right hand. So this is your right hand circularly polarized. Circularly polarized. Is that clear to you? Okay, let's see more example. Now what is the thing? Phase is pi by 2 only, but this guy and this guy is not same. One is E naught, other one is E naught by 2. One is E naught, other one is E naught by 2. So try doing it on your own and let me know what will be the structure. It will be circular, it will be linear, or it will be elliptical. It can be elliptical as well. So you try doing it and you let me know that it will be like, it will be a ellipse like this, or it will be a ellipse like this. So you think about it and let me know. Let's just call this as x-axis and this as y-axis. So you tell me no, you let me know that this will be the answer or this will be the answer. Okay, so try doing it. I will pause the video, drink some water, and then I will come back. Okay, you try doing it. Yeah, hi guys. So I'm back with a slight haircut and mehndi in my hand. So told you there is wedding season here, so that's why I need to take breaks in between. So did you try this question? In this question, what is the phase shift? Phase shift is pi by 2. So in the previous examples, what did we show? That when phase shift is pi, then it could be linear polarization. When phase shift is pi by 2, it is circular polarization. Here phase shift was pi by 2, so it was circular polarization. Here also phase shift is pi by 2, but the difference is this magnitude and this magnitude is not same. In the previous example, this magnitude and this magnitude was same. Now if this magnitude is not same, so we will analyze that what kind of polarization we will get. So let's analyze it. So how we are going to analyze? I have told you I need to stand on z equals to 0 plane because my wave is propagating in z direction. So what will be my electric field now? My electric field would be E naught cos omega t ax cap plus E naught by 2 cos omega t minus pi by 2 ay cap. Is that clear? Okay. So now let's see at t equals to 0. E naught ax cap at t equals to 0, this is 0 only. So let's make the diagram. So at t equals to 0, what you are getting? At t equals to 0, E naught ax cap you are getting. Let's just say this is x and this is y. So at t equals to 0, E naught ax cap. E naught ax cap. Let's check at t equals to t by 8. So what will be your omega t value at t by 8? 2 pi by t into t by 8. So that would be pi by 4. So if I put pi by 4 here, okay, let's do it. So if I put pi by 4, it would be E naught by under root 2, E naught by under root 2 ax cap, plus if I put pi by 4 here, so pi by 4 minus pi by 2 minus pi by 4, so E naught by 2 root 2 ay cap. Okay. So what do you see here? E naught by root 2, E naught by root 2 in x direction, E naught by root 2 in x direction, and E naught by root 2 by 2, E naught by root 2 by 2 in y direction, E naught by root 2 by 2. That means y direction is lesser amplitude, this amplitude is lesser. So let's just say this is the point. I am pulling this point with some x force, and here I am pulling with x by 2 force. So where it will go? It will go somewhere in between. I know that resultant will be somewhere in between, but it will be inclined towards the more force. Are you getting this point? If one guy is pulling you here, other guy is pulling you here, so you will go somewhere in between, but you will be inclined towards the more force. So this will be inclined, this resultant will be inclined towards x, right? Because in the x there is more force, there is more value, in the y there is lesser value, so you will be inclined towards x, right? So similarly more vector will come, they will be inclined towards x only. So what kind of ellipse you will get? This will be an ellipse only. You can see here the equivalent came somewhere in between, so I will remove it off. So first equivalent was here, then next equivalent is coming somewhere here in between, then next equivalent will come somewhat like this. So in that manner you will get the equivalent. Let's check for one more, no need to worry, let's check for one more. So if you put t by 4, then it would be pi by 2 only. Till now you must be comfortable with that. So at pi by 2 this would be 0, at pi by 2 this would be 1. So E naught by 2, E naught by 2 ay cap. So here you are having E naught, but on y direction you are having E naught by 2. Here the equivalent is E naught, but in y direction equivalent is E naught by 2. Okay. So that's why it is an ellipse, and ellipse which is tilted towards x axis. So it is an ellipse, but ellipse something like this. Okay. So I will show you the equivalents. These were the equivalents we were getting. So this kind of ellipse we will get. So this kind of questions can come. And how it rotated? It started from here and rotated in this direction. And what is the direction of propagation? Direction of propagation is plus z. So this is your direction of propagation. So which hand I need to use? Right hand, because thumb is pointing towards the direction of propagation, and this is the circulation, wave circulation, polarization circulation, whatever you can call it. So this is the circulation and thumb is pointing towards the direction of propagation. So right hand I am using. So this is your right hand circular polarization. Not circular polarization, sorry, right hand elliptical polarization, right hand elliptical polarization. So now what is the conclusion? So before watching the conclusion, let me write how would you determine the polarization, determining polarization. So we will make a table, basically determining polarization. We will make a table, how we will determine. So first I will see the phase shift. If phase shift is plus minus n pi, okay, if phase shift is plus minus n pi, where n is 0, 1, 2 and so on, then there is no doubt it is certainly linear polarization, linear polarization. Okay. But if the phase shift is plus minus 2n plus 1 pi by 2, starting from n equals to 0, 1, 2 and so on, basically phase shift is pi by 2, 3 pi by 2, 5 pi by 2, then along with that we need to check one more thing. that if your E naught x is equals to E naught y is equals to E naught. Basically, wave will be dancing in x direction, wave will be dancing in y direction. So both amplitude should be same. If that is the condition, then it is circular polarization. And rest all will be elliptical polarization. Rest everything will be elliptical polarization. So this is how you will determine. So first task would be to find the phase shift. You got to know if it is pi or pi by 2. Then you will think about circular. Otherwise, directly you will mark that it is elliptical polarization. So this summary I have written that if this is my electric field, the wave will be circularly polarized if the phase shift is multiple of pi by 2, odd multiple of pi by 2, I can say odd multiple of pi by 2. That means pi by 2, 3 pi by 2, 5 pi by 2. So odd multiple of pi by 2 and amplitude should be equal. And rest all the cases will be of elliptical polarization. What I have written is that the phase difference cannot be n pi, because if phase difference is n pi, then certainly it would be linear polarization. You do not even need to think. If phase difference is n pi, then it will be on one line only. So phase difference cannot be n pi. This I have written, and E naught x cannot be equals to E naught y. But this is not a necessary condition, right? Because even for this condition as well, like E naught cos omega t minus beta z plus ax cap and E naught cos omega t minus beta z plus pi by 4 ay cap. So here as well it will be elliptically polarized. Although this E naught is same, but still it is elliptically polarized. Why so? Because phase shift is pi by 4. If phase shift was pi, then it would have been linearly polarized. If phase shift was pi by 4, then it would if phase shift was pi by 2, then it would have been circularly polarized. But if any other phase shift is there, then certainly it is elliptically polarized. So this conclusion that I have written is not correct actually. What I will write, rest all the case, or let's not write anything. Okay. So rather than looking at this, we will look at this guy. So this is the complete conclusion. That determining polarization. How would you determine the polarization? This is the complete conclusion. What is the conclusion? First see the phase shift. If it is multiple of pi, 2 pi, 3 pi or 0, then it is linearly polarized. If it is odd multiple of pi by 2, then it would be circular polarization if amplitude are equal. And if any other case is there, then certainly elliptically polarization. Okay, let's start with this question. Try doing it on your own and let me know your P average as well. What is P average? Time average pointing vector. You need to tell me the time average pointing vector. Along with that, you need to tell me the polarization as well. So think about it. You can tell because we have done enough practice. So certainly you will be able to tell what is this. This is your phasor form. So can I break it down like this? E naught e to the power minus j beta z ay cap minus j e naught ax cap e to the power minus j beta z, right? Just I broke it down. If I write down the time term, so how will I write down? E naught, I will just add e to the power j omega t and will take real part. So cos omega t minus beta z ay cap. What is this minus j? Minus j is the e to the power minus j pi by 2, if you remember it. If I want to remove this minus j, what I can do? I can simply put plus here and this would go into minus pi by 2. Is that clear to you or not? So what I can write? Plus E naught cos omega t minus beta z minus pi by 2 ax cap. What is the phase shift? Phase shift is pi by 2. You can write plus pi by 2 or minus pi by 2, just which one is leading, which one is lagging, you do not need to think about it. So what is the phase shift? Phase shift is pi by 2. Phase shift is pi by 2. Right? So which kind of polarization is that? Directly you will not say it is circular polarization. Why is that so? Because first you need to see that these amplitude are same or not. So yes sir, these amplitude are same, then certainly it is circular polarization. But right hand or left hand, for that you have to do the analysis at least 2 times. So let's do the analysis at least 2 times. So at t equals to 0, what you are getting, and z equals to 0 also I will put. Certainly z equals to 0 also I will put, because I will be dancing on xy plane. Not I will be dancing, wave will be dancing on xy plane. I will be just sitting there. But tomorrow I will have to dance. और मेरी शादी नहीं है भाई, ठीक है? मेरी शादी नहीं है. It's not my marriage. मेरी कजिन की है, या तुम लोग कहीं कह दो यार कंग्रेचुलेशन कहने लगो. So wave will be dancing on z plane. Okay, so z equals to 0 and t equals to 0. If I am putting at z equals to 0, I am checking, so I am gonna put t equals to 0. So E naught ay cap, and this is cos pi by 2 will be 0 only. So E naught ay cap, initially we are getting E naught ay cap. This is the equivalent we are getting, E naught ay cap. At t equals to t by 4 we can check, or t by 8 we should check. T by 4 we can check, I guess. Yeah. So which equivalent you will get? T by 4, T by 8, anywhere you can check. So what will be T by 4? What will be omega T value? Omega T value will be pi by 2, right? So cos pi by 2 is 0 only. Cos pi by 2 is 0 only, and cos 0 is pi by 2 minus pi by 2. That would be cos 0. Cos 0 is 1. So E naught ax cap you are getting. E naught ax cap. So in which direction we are moving? If we make a circle, basically in which direction we are moving? We are moving in this direction, from here to here. This was initially at t equals to 0, and this is at t equals to t by 4 we are getting. Okay. What is the direction of propagation? Direction of propagation is again plus z. If this is x, this is y, where will be my z? Z will be coming towards me, and this is my direction of propagation only. So which hand I have to use? Left hand, right? Left hand I will use direction of propagation towards me. So this is your left hand circular polarization. Is that clear to you? Okay. A very good concept. Again, let me tell you, if you see these kind of things, directly you should be able to write down this. That minus j would be minus pi by 2. So directly I will be writing down the phase. Then I would know that it is circular polarization. But if they ask left and right hand, so I will put t equals to 0. At t equals to 0, cos 0 is 1, and that is cos pi by 2. That would be 0 only. And then at t equals to t by 4. So what that would be pi by 2. So cos pi by 2 is 0, and but here cos 0 is 1. So initially I was at y, and then I was at x. So the circle is going, and in this direction it is going. I have to use left hand. Okay, so left hand I am using. So left hand circular polarization. Let's see this question now. Try doing it on your own. Now I will write down the function, and you let me know, can I write it down in this manner? E is equals to under root 2 cos omega t minus beta y plus pi by 4. Did you understand what did I do here? How much phase shift this guy will provide? J is providing you pi by 2, e to the power j pi by 2. So what will be your 1 plus j? 1 plus j will be under root, how much angle? Tan inverse 1. Tan inverse 1. Angle will be tan inverse 1. So that would be pi by 4 only. So under root 2 e to the power j pi by 4. So that is pi by 4 only. So under root 2 cos omega t minus beta y plus pi by 4 ax cap. Is that clear? Is this clear or not? Okay, here we forgot to write down the time average pointing vector. What will be your time average pointing vector? P average. P average, for P average what do I need? E naught square plus E naught square, then square of that divided by 2 eta. Okay, so what you are getting? E naught square by eta. Basically from here only you could have told that's our E naught, and this magnitude will be under root 2. Why under root 2? Basically I need to divide by under root 2 so that this becomes a direction, and then I will need to multiply by under root 2 as well. Why under root 2? Why not this 1 plus minus j whole square? Why not this? I told you j is just a phase. So 1 plus 1, so under root 2. So E naught under root 2 is my magnitude. So E naught under root 2 whole square, E naught under root 2 whole square divided by 2 eta. That is the answer. So what you are going to get? E naught square by eta, right? So answer is E naught square by eta. So this we have already seen in time average pointing vector in a very in-depth manner we have seen. Along with that we saw it in the wave propagation in general medium. In that concept as well we saw it. I hope the sound of cracker are not disturbing for you. I hope you are able to concentrate. Or should I pause the video? अब वैसे पटाखे तो बजेंगे यार, शादी है, आखिरी बार बजाएंगे शांति से, वैसे तो बजाएंगे. Yeah, so 1 minus j, 1 minus j. So how much phase shift this will provide? 1 minus j. In x direction 1, in y direction minus j. So what will be the phase shift? Minus pi by 4, right? This much basics we have already covered in vector algebra and all these kind of things. So you should be able to tell how much phase shift you would be writing. Okay, so cos omega t minus beta y minus pi by 4 az cap. What is the phase shift you see here? Pi by 4 minus of minus pi by 4, right? Pi by 4 minus of minus pi by 4, that would be pi by 2. Phase shift is pi by 2. So what kind of polarization is that? Circular. Circular. Okay. Left hand, right hand. If they ask this thing, then what you need to do? You need to analyze. So what I am gonna analyze at t equals to 0. Certainly at z equals to 0 I am gonna put. So at t equals to 0, what is my E? So under root 2 1 by under root 2 Ax cap plus under root 2 1 by under root 2 Ay cap. So what you are getting? Ax cap plus Ay cap. So this is a bit interesting, although not difficult, but a bit interesting, like something different is there, right? Yeah, this is what I was thinking. It is z, sorry, this is z, not y. So which plane I am gonna make? X and z I am making. So where will be my y? X cross z, x y z, z cross x should give you y, so y would be inside. So I don't want to make y inside, so what I am gonna do? I am gonna put z here and x here, okay, because z cross x should give me y. So this will be my y now. This is my y. And at t equals to 0, where you are getting the equivalent? Right in the middle. You are getting the equivalent right in the middle. Okay. Let's check at t equals to t by 8. Should we check at t equals to t by 8? Okay. Let's check at t equals to t by 8. So what is omega t? 2 pi by t into t by 8. That would be pi by 4. Pi by 4, pi by 2. So that would be gone. Pi by 4, pi by 2. That would be gone. Pi by 4 minus pi by 4 under root 2 az cap. Under root 2 az cap. That equivalent is coming here. How did I tell circular polarization? I saw this magnitude as well, okay? This magnitude as well, under root 2, under root 2. That's why I am saying it is circular polarization. So this magnitude is also under root 2, this magnitude is also under root 2 only. So circle, we can see what kind of circle is there. This circle is there, right? And in which direction this wave is moving? In this direction. And what is the direction of wave propagation? Direction of wave propagation is plus y. So direction of wave propagation is plus y. So which hand you need to use? Left hand, because finger should point towards circulation and thumb should point towards the direction of wave propagation, which is coming towards me. So left hand circular polarization. Okay. These are the very good example which I am taking here. I am not taking standard example. Standard example you will be able to solve. There is no doubt about that. But these are very good example. Like here, straightforward things you cannot see. These are not very straightforward, right? So it will take you some effort. It will take you some time. So that is a pretty good thing for you. And now if you need to write down time average pointing vector, then what it would be? So under root 2 here, under root 2 here. So under root 2 whole square plus under root 2 whole square. Then what I need to find is that I need to find E naught square, right? So what will be my E naught from here? What will be my E naught? My E naught will be, this is in x direction, this is in y direction. They are perpendicular to each other. So under root 2 whole square plus under root 2 whole square and then under root of that. This will be your E naught. And if you take E naught square, what that would be? Under root 2 square, that would be 2 only. And this should also be 2. That would be 4 by 2 eta. So that means 2 by eta. Are you getting this point? How I am getting E naught? Basically, E naught is 2 plus 2 under root 4. Under root 4. So E naught square by 2 eta. That would be the answer. So 2 by eta is the answer. Is that correct? Are you able to understand what we are doing? So these are very good example. If you are able to solve, then it is pretty good for you. And certainly you are learning something new. So this is the max limit that they would be asking in the examination. So do not worry that any tough would be coming. Try doing this question. Okay. This is the max limit. If you are able to solve this one, then you have understood everything. Like you can draw the diagrams, you can do anything. Take k is equals to positive. Okay. K is some positive integer, you can say. K is positive. This we need to take. draw the diagram, think about it, like completely think about it. Where will you take a plane? What is the direction of propagation? What kind of polarization it would be, and left and right hand? Just think about it. Take your time. I would say spend 10 minutes here, because it will clear a lot of concept. It will also clear whether you are able to write down, whether you are able to make the diagram or not, whether you are able to visualize or not. So my wave is propagating. What is my k vector? If you tell from here, what is my k vector? K ax cap minus k ay cap. So my k vector you can see here. So x y I am making. This is my x and this is my y. So positive x and negative y. Positive x and negative y. So this will be the direction of wave propagation. This is the direction of wave propagation we are making. So this is your wave propagation direction. Is that clear to you? Now where is your electric field? So for electric field, plus ax plus ay, and one is in the z, and this j is telling that the z direction electric field is 90 degree ahead. That means the phase shift is 90 degree. Are you able to understand this point? Electric field is in x direction as well, it is in y direction as well, and it is in z direction as well. It is in positive x and positive y. So what will be the equivalent? This will be the equivalent. Let's not use green color of pen, let's use this color pen. This will be the equivalent. Along with that, there is another electric field which is in z direction. This is our z, right? This is our z. Another electric field is in z direction. So the electric field which is in x and y, it has the equivalent of under root 2, because ax plus ay, what I am doing is that I am breaking it down in this manner, that E naught e to the power minus j omega t minus k dot r I am writing, okay, ax cap plus ay cap plus, here phase shift is j, more phase shift is here, E naught, more phase shift is there, plus 2 E naught, 2 E naught plus j 2 E naught e to the power minus j omega t minus k dot r az cap. Okay, this is how I am writing it down. So this is not the direction. For direction it has to be unit vector. So for direction it has to be unit vector. So I will multiply with under root 2 and divide with under root 2. For direction it has to be unit vector. And how would you write down unit vector? Ax cap plus ay cap. You need to divide by its magnitude. So that would be under root 2. So if I am dividing by under root 2, I will have to multiply by under root 2 as well. So 2 E naught under root 2 E naught cos omega t minus k dot r ax cap plus ay cap divided by under root 2 plus 2 E naught cos omega t minus k dot r. Minus j, minus sign is already there. So j omega t. So from here, if I take the minus sign, look, minus j omega t. Actually, this minus sign should not be there. Okay, this is an error. This minus sign will not be there. This minus sign will not be there, because that will come along with the direction, no? Like e to the power j omega t will be added, and e to the power minus j kx minus ky. It should be the condition, no? Like this is the direction of wave propagation, and this is time term you are adding. You will never add e to the power minus j omega t time term. We add e to the power plus j omega t. So the minus sign will not be there. Okay, so that was an error. I just now noticed it. So this minus sign will not be there. Okay, so yeah, in the same manner we are proceeding. Then az cap. Okay, now phase shift is also there, no? Phase shift is j, so it would be plus pi by 2, plus pi by 2 az cap. So what is the phase shift? This is the direction, this is also direction. Now this is pure magnitude, this is also magnitude. So what is the phase shift? Phase shift is pi by 2. Here phase shift is pi by 2. But here E naught x is not equals to E naught y. Right? E naught x is not equals to E naught y. So that means it is elliptical polarization. Elliptical polarization. Elliptical polarization. Now left hand or right hand, think about it. Take your time. Where will be my plane? My plane is always perpendicular to the direction of propagation. So this is the direction of propagation. So where I will assume my plane? So I will assume my plane somewhere here. This is how I am gonna assume my plane. This is the plane I am assuming. Okay. Now on this plane, along with this plane, we have two directions. One is ax plus ay. Basically, if I draw the plane, how the plane will look like? This is my ax plus ay and this is my az. This time here I am not writing x z or y z, anything like that. No, this is ax plus ay. If you, this is the direction of wave propagation. This is the direction of wave propagation, and here I will assume the plane. Here I will assume the plane. So one electric field is in ax plus ay. Other electric field is in z direction. So this is what I have shown. Is that clear to you? Here you can see no ax plus ay. Here I should write ax plus ay divided by under root 2. Unit vector I should write, and here I should write az. Is that clear what I am doing? Okay. Now I need to put z equals to 0. I need to put z equals to 0. So the z equals to 0 means, what do you mean by z equals to 0? What will be the equation of this plane? Can anyone let me know? What will be the equation of this plane? So whatever the equation of this plane is, if I put in the previous cases, here I was putting y equals to 0. So this k dot r term was coming 0 only. This k dot r term was coming 0. Whenever I was putting the equation of plane, here the equation of plane was y equals to 0. So this k dot r, this was k dot r only. This was also k dot r. So that was going to 0. If you are not understanding what do I mean by k dot r, you need to watch the oblique incidence video. And there we studied wave direction of wave propagation in a general medium. Not in general medium, sorry, in a general direction. Wave propagation in a general direction, that we have studied in one of the videos. There we talked about k dot r. So this k dot r will certainly come 0. So on this plane, k dot r will certainly be 0. Do you agree to this point? K dot r will certainly be 0. And this is the equation of this plane. The equation of this plane would simply be, what is your k dot r? K dot r is, if you take minus outward, kx minus ky is equals to 0. So this is the equation of this plane. The equation of this plane is kx minus ky is equals to 0. So at that point, k dot r will be 0. So no xy term will come. Basically, we are going on a constant plane. So there no xy term will come. So this term will go to 0. Are you getting this point? So these two terms will go to 0. So now we need to draw this diagram. So that we will make on next page. So let me add a page. So at the plane k dot r is equals to 0. So what will be your E field equation? Under root 2 E naught cos omega t ax cap plus ay cap divided by under root 2 plus 2 E naught cos omega t plus pi by 2 az cap. Now if I put t equals to 0, what do I get? At t equals to 0, E field you are getting is under root 2 E naught cos omega t ax cap plus ay cap divided by under root 2. Okay. So under root 2 if t equals to 0. At t equals to 0, cos 0 would be 1. At t equals to 0, cos 0 would be 1. And at t equals to 0, cos pi by 2 will be equals to 0. So that term will be gone. So this is what you are getting. So let me make this graph here only. divided by under root 2, and this is your Az cap. So this equivalent here we are getting. Now at t equals to t by 4 or t by 8, I also can check. Let's check at t by 4 only. So at t equals to t by 4, what will be omega t? 2 pi by t into t by 4. That would be pi by 2. Okay. So cos pi by 2 is 0. So this term will be gone. And pi by 2 plus pi by 2 would be 1. So what you are getting? Minus 2 E naught Az cap. So minus 2 E naught Az cap. So here the equivalent is minus 2 E naught. Here the equivalent was 2 E naught. So this equivalent is larger and that equivalent was smaller. So here the equivalent is 2 E naught minus Az cap, and here the equivalent was under root 2 E naught. So which equivalent is larger? The lower one. So how will the ellipse look like? Ellipse will look something like this. Ellipse will look something like this. Right? So this is how the ellipse will look like. And which kind of polarization is that? Elliptical polarization. And what is the direction? This is the direction, because at t equals to 0 you are getting this, right, which is under root 2, and at t equals to t by 4 you are getting this. At t equals to t by 4 you are getting this, which is 2 E naught. We are going from here to here, under root 2 to 2. And if you use your, and what is the direction of propagation? The direction of propagation is perpendicular. Basically, direction of propagation. If you need to see the direction of propagation, so this was your wave and this was your jet. So how will I determine the direction of propagation? This direction cross coming towards me. So this is the direction of propagation. So if I determine the direction of propagation on this plane, so this cross this should be the direction of propagation. I know you are not getting it. So place your fingers here. Place your fingers here. And the other part is coming towards you. I am just talking about electric field. Placing the finger here, other part is coming towards me. So if I do the cross product like this, from Ax, how I am doing the cross product? Ax cap plus Ay cap divided by under root 2 to Az cap. I am going from here to here. If I use my right hand and I go from Ax cap plus Ay cap divided by under root 2 to Az cap, then thumb shows the direction of propagation. So similarly on this plane, if I go from Ax cap plus Ay cap divided by under root 2 to Az cap, then the thumb should show me the direction of propagation. So this is my direction of propagation. Direction of propagation is coming towards me. Is that clear to you? How I am determining the direction of propagation? This requires a very high amount of intelligence to solve these kind of problems. Okay, like till here everyone will be able to tell that this is elliptically polarized, but no one will tell you whether it is left hand or right hand. I can guarantee you, you can see in any textbook anywhere, no one is telling you these kind of analysis. Okay, I am not being arrogant here, but what I am saying is that this is a very deep analysis that you are going to learn, and this is the max they can ask in the examination, in any examination I am talking about, or in any interview I am talking about. Okay, so yeah, so this much aptitude you should have, that how we are doing it. So wave propagation was there, we assumed a plane perpendicular to the direction of propagation, then we saw the electric field. Electric field is having two components, one is like this, other one is coming towards you. So these two components it was having. If these two components it was having, now I needed to make a different plane. At this plane k dot r is equals to 0. So that plane I made. And from this expression, this is how I broke it down, that this j is just giving the phase shift. So phase shift is pi by 2, and this is how I broke it down. I got to know that this amplitude is no same pi, and phase shift is pi by 2. Certainly it is elliptically polarized. Now I need to make the diagram to tell whether it is right hand elliptically polarized or left hand elliptically polarized. So for that what I need to do? I need to make the diagram. So for that what I need to do? K dot r should be put equals to 0, because on this plane k dot r will be 0. This is what we were doing. Beta y equals to 0, beta y equals to 0 here, beta z equals to 0. We were putting z equals to 0. So basically we were writing down the equation of plane, so that we were putting equals to 0. So k dot r was going towards the 0. So here also k dot r is going towards 0. So what we are left with? We are left with this expression. Now I am putting t equals to 0 and t equals to t by 4. So at t equals to 0 you are having under root 2 E naught, and at t equals to t by 4 you are having minus 2 E naught. Okay, so that means this is how it is moving. The circulation is like this. Circulation is like this. So now you need to check whether it is left hand or right hand. So I need to use my left hand, because this is my direction of wave propagation, and this is the circulation. So I need to use my left hand. So it is left hand elliptically polarized. So this is the complete answer, and that's the best limit, or that's the maximum limit they can go. I hope you must have understood the complete analysis. And how did I determine the direction of propagation on this plane? How did I determine that? You can see from here as well that if this is your plane, then direction of propagation will be perpendicular, but it will be coming towards you or going into the screen. That you need to understand. Then how did we understand that the axis that we are making? What is the axis that we are making? This is my ax cap plus ay cap divided by under root 2, and this is my az cap. So if I need to tell the direction of propagation, where is the direction of propagation? If I have another pen, so this is my ax cap plus ay cap under root 2, ax cap plus ay cap under root 2, and this is my az cap. So what is the direction of propagation? The direction of propagation is, if you place your hand here and move it like this, then this is the direction of propagation. Place your hand here and move it from ax cap plus ay cap to az cap, then this is direction of propagation. You see in the diagram as well. This is how I take my hand and then I rotate my finger. So this thumb is showing my direction of propagation. So same thing I am gonna do on this axis as well. From here to here I will rotate. So this is showing me my direction of propagation. Is that clear to you or not? Okay. So this is the direction of propagation, and from there you go to know that it is left hand elliptically polarized. Okay, because I need to use my left hand. Is that clear to you? So a very good question, a very good analysis as well, and every single thing which can be studied from this particular expression that we have studied. And if someone asks you the time average Poynting vector, what will be your answer? P average if they are asking. So E naught square I need to tell. What will be my E naught square? What do you think? This guy and this guy is perpendicular. Right, this guy and this guy is perpendicular, so certainly I can write down root 2 E naught square plus 2 E naught square divided by 2 eta. So 2 E naught square plus 4 E naught square, so 6 E naught square by 2 eta, that would be 3 E naught square by eta. That is the answer. Okay, 4, 2, 6, 6 by 2, 3 E naught square by eta. Let's answer this question. Which of them are elliptically polarized? What do you think? You broke it down, what you will get to know. This is having a phase shift of pi by 2. But here amplitudes are equal. You do not think that sir amplitude one is having 25 amplitude, other one is also having 25 amplitude. No. If you break it down, how will you break it down? 25 sine omega t plus 4x plus 60 degree ay cap plus j az cap would come. So j is phase shift pi by 2 only. So 25 sine omega t plus 4x plus 60 degree plus pi by 2 az cap. So what is the phase shift here? This minus this. So phase shift is pi by 2. Phase shift is pi by 2. And this guy and this guy is equal. So basically your E naught x is equals to E naught y is equals to E naught. So this is circular polarization. Okay, this is circular polarization. What is the phase shift here? If I ask you the phase shift here, what will be the phase shift? 45 degree. It could be plus 45, it could be minus 45, but you should be able to think. Break it down, then you will be able to think. And E naught x is, and what is your E naught y here? E naught y is 25. And what is your E naught x here? E naught x is 25 under root 2. Say yes or no. What is your E naught x? Are you able to understand why it is 25 under root 2? Because of this guy. So 1 plus j is simply under root 2 and phase shift of pi by 4. That's it. So phase shift of 45 degrees there. E naught y, that means y is having one amplitude, that is 25 only. So 25 into 1, and this is 25 into under root 2. So what kind of polarization is that? Elliptical. So this is correct. What about this? This is also elliptical. Why is that so? Because phase shift is 30 degree. If there is any phase shift other than pi and pi by 2, you do not even need to think about it. Certainly it will be elliptically polarized. The phase shift is 30 degree. What is the phase shift? 30 degree. So I do not even need to think. What about this guy? What about this guy? What about D? So this will give you under root 2 e to the power minus 45 degree. And this will give you under root 2 e to the power plus 45 degree. So amplitude is same. And what is the phase shift? Phase shift is 45 minus 45, 90 degree. Phase shift is 90 degree. Amplitude is also same, no? Under root 2, under root 2. Amplitude is same and phase shift is same. Basically, amplitude is 25 under root 2, 25 under root 2, and phase shift is 90 degree. So which kind of polarization is that? Circular. So this is also circular. Okay, so these two options are correct. This D is also circular. Is that clear? Is that concept clear? So this is the end of our polarization, and I hope you enjoyed the video. I hope you enjoyed this question. This was the best one which anyone would ask. So this kind of aptitude you should be having, that how we would be solving these kind of questions in the examination. The like at least you will be able to tell it is elliptically polarized just by looking at the expression. What you will think, that this will give, this is the different term which is giving us a phase shift of pi by 2. So that means I need to take this aside. Why I have taken these and these aside? Because I know that this guy was giving me a phase shift of pi by 2. So that's why I took it aside. So that pi by 2 phase shift I took aside. Okay, so this is the phase shift that I am getting. There I go to know that this will give an amplitude of root 2, but this will give an amplitude of 2. So root 2 and 2 both are not equal, then certainly it is elliptically polarized and phase shift is pi by 2. Left and right hand, that is something you need to draw the diagram. So first you see how the wave is propagating, then you need to take a plane. So for that plane, k dot r will be equals to 0. So that term will be gone, minus kxy plus kx plus ky, that term will be gone. Only omega t term will be left. So you can make the cosinusoid function. If you make the cosinusoid function, you put t equals to 0, you put t equals to t by 2. Then you make this particular plane. So if you make this plane, then what you will get to know, on x-axis I am putting, no sorry, I shouldn't say x-axis. On horizontal axis I am putting ax cap plus ay cap divided by under root 2, and on vertical axis I am putting az cap. Now where will be my direction of propagation? So again I need to go to this diagram. So how I can get the direction of propagation? If I use my right hand, and then if I place my hand like this, that this is my electric field, another electric field, and if I rotate my hand towards another electric field which is coming towards me, then this thumb shows the direction of propagation. So same goes here. I will put my hand like this, and if I rotate my fingers towards az cap, then direction of propagation will be coming towards me. So this is my direction of propagation. This is my direction of propagation. So now I know at t equals to 0 I put the value, at t equals to 0 and at t equals to t by 4 I put the value, then I go to know that this is how it is rotating. So which hand I need to use? I need to use left hand. So it is left hand elliptically polarized. Is that clear to you? Okay, very good. And these questions we saw. So here we saw that 25 is common, so forget about it. So here we can see 45 degree phase shift, elliptically polarized. Here we can see 30 degree phase shift, elliptically polarized. Here we can see 90 degree. Here also we can see 90 degree. But here the catch is the amplitude are same. Here also under root 2, and here 1 1. So that's why they are circularly polarized. That's it. That's it about this particular chapter, which is polarization. And if you are thinking that we are not able to understand what is k dot r and whatever these things sir is teaching, so you need to understand this from complete playlist. So study it right from the beginning, then only you will be able to understand. Okay, yeah, thank you very much. I hope you enjoyed it. You can drop a like and share it with your friends. Thank you very much.